Okay, if you can remember, we have discussed these things last day. States of matter we have started. We have said solid, liquid, and gas. Then we have showed you how to draw if they ask how to draw. So solid, liquid, and gas. So if they ask you to draw the diagram of solid, liquid, or gas, so you must give at least 3 rows and 5 columns. 3 circles, 5 circles in a row, and you make three rows total. You understand? 5 circles in a row. So at least show up to this. So you show part of the structure. So if you want to draw all these circles, your exam time will go out. So don't do. So that is how you need to draw. They sometimes ask you to draw the diagram in solid, liquid, or gas. So that is it. And we have discussed their properties. So you can study properties from here, or I can give you a chart. Basically, I don't want to give note. That's why I don't give you. If I give note, if I provide note, then you don't study books. That is a problem. So you see states of matter. At the end of the day, you will get this note, inshallah, in future when your book study will be finished. Then see 1.2 states of matter. See solid, liquid, and gas. Strong force of attraction between the particles. Fixed pattern or lattice. Fixed pattern, fixed position. They have fixed arrangement. Atoms vibrate, but they cannot change their position. So that's how you need to write. Number 1. Number 2, if you study from this book, another book, which is the Cambridge book, IGCSE chemistry. If you study from 1.3, it's in 1.3, and you can write the page number if you want. Page number 10, and it's given in Google Classroom. You see solid, the particles in a solid are arranged. They are arranged properly in a fixed position or in lattice structure. So very regular arrangement. Strong forces held them together. So they have strong force of attraction in between them. So they cannot leave their position. The only movements they make are tiny vibration to and from. It's tiny vibration in a fixed point. So you can make your own note if you want. Yeah? So from all these informations, you can make your own note. And I gave you the points by which you should answer. So liquid, the particles in liquid can move. So you can see these stuffs. So that is it. Let us Then change of state we have discussed from this book last day. See melting and freezing, you can remember, solid to liquid and liquid go back to solid. Then liquid to gas and gas back to liquid, and solid to gas and solid to gas and gas back to solid. So if we show it was something like that. If you look at this, it was something like that. In a triangle we have showed, see solid to liquid, melting and freezing, liquid to gas, vaporization or evaporation and condensation. Vaporization, you can say it's boiling. There are many terms used by many different books. Boiling or evaporation, you can say. So both are vaporization. Vaporization, see, risation means formation of vapor. So how will do? You need to boil it, or they will evaporate naturally to form gas. And again, liquid to solid is freezing, and gas to liquid is condensation. Solid to gas is sublimation, and gas to solid, if you reverse back, it is reverse sublimation. In some books you will find they will say deposition. In some book you will find they will say solidification. So all these are synonymous terms. Any question up to this?
Awesome.
So you can take information from anywhere, but make sure you understand here. You are not memorizing, you understand in your, it's the concepts are inside your brain. And when we will ask you MCQ and stuffs, you will be able to answer. Up to this, good enough. Good enough. ঠিক আছে। এরপর নেক্সট পয়েন্টে আমরা যদি যাই, দেন ওই যে এটা বলতেছিলাম আমরা solid to gas and gas back to solid deposition. আচ্ছা, next point is we want to say one thing is, say for example, what is the melting point of water? Do you know? At what degree centigrade water will melt? From ice, it will form liquid water. Do you know?
Say 0 degree.
Very good job. So it's 0 degree centigrade, right? So this is the melting point of water. And what is the boiling point of water? Do you know?
100 degree.
100 degree centigrade. Very good. So this is the boiling point. Now, if you look at, they will ask you a question for 1 mark in maximum pages, and they will ask this question in every year, whether it is in Edexcel or Cambridge or IB. They are asking this question for you can say last 12 years. They are asking the same question again and again in different format. What you need to understand is what for any element or substance or any compound, you have melting point and boiling point. Now, if you can identify, or if you have the information of the melting point and boiling point of anything, any entity, then if I ask you what is the condition, this is the melting and boiling point of water, and if I ask you what is the condition of water, if you keep water at 50 degrees centigrade, what is the condition? Solid, liquid, or gas?
Liquid.
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 How do you know?
Because it's getting boiled.
No, it's not getting boiled. At 50 degrees,
it is in the
what is the
stage
condition of
between
water?
liquid.
It's a room
Sorry, solid and
temperature.
It's not room temperature. Basically, we know this.
Say
degree centigrade,
because
water
it's above 0 and below 100 degree.
exactly that. This is the answer I want. You see, not only for water, for any compound, any substance, if the temperature mentioned is in between melting and boiling point, your state will be liquid. You understand? Any temperature.
Yes, sir. Now I get it.
At 1 degree,
Sir,
at
this
2
is
degree, at
what
10
we call
degree, at 90
plasma.
degree, at 95 degree, in all these conditions, in between 0 and 100, water will be liquid. Is it clear?
Yes, sir.
Okay, very good job. So above the boiling point, any temperature mentioned, say 2000 degree, 101 degree, 105 degree, 200 degree, at any temperature which is above boiling point, if I ask you what is your condition of water at 120 degree, you will say it is gas. If I ask why, you will say it is more than the boiling point, sir. ঠিক আছে? Here.
Yes, sir.
Okay, very good job. So any temperature above the boiling point of any substance is a gas. And the last one, any temperature below the melting point. So below 0 degree, what we have? -1, -2, -200, -20, -50. So any temperature below the melting point is solid. So please look at this concept properly and try to understand what is happening. 1 mark is ensured. 1 mark. If you understand this. Fine. And
Yes, sir.
take the note if required. Take the note. Take your note. Or take a screenshot. Done?
Yes, sir.
Okay, very good job. So let us check whether you understood or not. Let us check the concept. Okay, we are going to the end of chapter question of the Pearson book. What is what name is given to each of the following changes of state? Who will say? I'm asking. Wait. Okay, Taiba will tell. Taiba will tell. Solid to liquid.
So melting.
Melting, done. Then next one. Liquid to solid.
So liquid to solid, freezing. Solid to gas.
Solid to gas.
Solid to gas is sublimation.
Sublimation.
Yeah. And gas to solid is solidification.
Okay, solidification, deposition, or reverse sublimation, anything you can say. Very good job. Then number 2 you can do now easily, but we will not do here. Draw diagrams to show the arrangement of particles in solid, liquid, and gas. So I say give 5 circles in a row and make at least 3 circles. Okay, at least 3 circles. That's how you need to give for solid or liquid at least. Liquid, the particles will be a bit irregular, and solid, the particles will touch with each other. So that's how we need to go. Describe the difference between movement of particles in a solid and liquid. We have completed. We have said the change of the state from a liquid to gas can be either evaporation or boiling. Difference, give the difference. We will discuss this later on. We didn't discuss it yet. Number 3 is our point of discussion now. The question refers to the substances in the table. So A, B, C, D, and E are the 5 substances. Write down the physical states of each compound at 30, -100, and 80 degrees. Who want to answer this? We are starting with. Again, Taifa will start. Ye will start. Taiba will start. Taiba, tell me. For number A, you discuss for number A first. আচ্ছা, number A আমরা লাস্টে করি, সবার লাস্টে। এটা একটু complicated. Number B থেকে start করব। Start with number B. Write down the physical state of each compound at 30 degree. At 30 degree, what is the condition of B? Solid, liquid, or gas?
So liquid.
Liquid. Why?
Sir, because the melting point is 0 and boiling point is 100 and 30 is in between this temperature. That's why.
Exactly, very good job. That is the exact answer. Because it's in between melting point and boiling point. Done. Next point, number 2. B at -100 degree.
So it's a solid
Why?
because it's less than 0.
Is that is
The
less
temperature
than
is negative.
It's less. What you need to answer is it is less than the melting point, sir. The temperature mentioned is less than the melting point, sir. ঠিক আছে? Okay, very good job. Number 3.
So it's solid.
Number 3. 80 degree. What is the condition of B at 80 degree?
Gas, I guess.
So it's more than it's liquid since
No point of guessing. It is 80 degrees centigrade. What is 80 degree? In between 0 or 100, or above 100 or below 100, below 0?
In between 0 and 100.
so in
0 and
between
100. So any temperature mentioned, if it is
it
in
will be
between
liquid since in between melting and boiling.
are liquid. Okay, very good job. ঠিক আছে? I hope everyone understood. And if you don't understand, then ask me now.
I got the B, yeah.
আবার বলতেছি, any temperature below the melting point is a solid. Above the melting point and below the boiling point means in between melting and boiling point, it's a liquid. Above the boiling point, it is a gas. Is it clear?
If it was 120 degrees Celsius, it would have been gas, right?
It will turn to gas, right?
Okay.
Okay. So it's B is done. For B, substance B, we have completed. Right. Next point. We will do for number D now. Number D. Who will tell? Ifa.
Me.
Okay, you will
Oh.
come. Who want to tell? Ayman.
Yes, sir.
Okay, I'm until.
Sir, can you repeat the question?
Question is written. Write down the physical states of each compound at 30 degree. We are asking for D. What is the condition of D at 30 degrees centigrade? First, Ayman Mahdi, you there? Don't write anything in the chat box. Ayman. Ayman.
Sir, I'm not sure about it.
So why you are writing in the chat box? Other student need to listen what you say. Okay. If you are not sure, then you are in trouble. I'm saying. খুব ভালো করে বলছি যে you take two benchmark, melting point and boiling point. See, melting point and boiling point. What is the melting point? Is negative 116. And what is the boiling point? 34.5. So 34.5. You see, if this is your x-axis, y-axis, and this is your x-axis, you know this one is x prime and x. So this is 0. So these are negative. So negative 10, say negative 20. So that's how it goes. And negative 116. And this one is positive 34.5. So you need to understand the axis, what is going on. So now see, I said 30 degree. Where is 30 degree? Where is 30 degree here? It or not? 30 degree. This position. Response. This is 30 degree, right?
Yes, sir.
Okay. If this is 30 degree, it's in between melting and boiling point, right? This
Yes,
point
sir.
is in between melting and
It
boiling
is
point.
at the boiling point, na, sir.
Right.
I mean, closer to the boiling point. So it might be liquid.
Now, not might be. You cannot utter this word might be. It is less than boiling
Okay.
point and more than melting point. Means it is in between melting and boiling point, 30 degree. It means it is definitely liquid. You cannot say it might be liquid. It is liquid, for sure.
Yes, liquid.
Okay, number 1 point. Number 2, negative 100. Where is negative 100? Where should negative 100 lie?
At the melting point, closer to melting point.
Not close. You cannot say in this way. It's not closer to melting point. What you need to say is, sir, negative 100 is here. Say here. This is negative 100.
Oh, like this. Okay.
Right? So negative 100
Okay.
is definitely in between melting and boiling point again. So this is also liquid. Right?
Yep, sir.
Okay. Next point. Last. It's positive 80 degrees centigrade. So this is 34.5. So 80 should be here.
Yes.
So it is above the boiling point, right?
Yes.
Above the boiling point means?
Yes. Yeah.
Yes. Sure. Fine.
Yes, I got it.
Okay. The last thing I will discuss now, and if you still don't understand, please go back to the video and please look at or ask me now. Ask me now. Okay, next point I'll say.
Sir,
Okay, thank you. Melting point, boiling point. We'll do number A now. The last thing. Afrin neutral, Afrin. Number A. 30 degree. What is the condition?
Solid.
Solid. Why? Give your reasoning. Melting point is negative 259 degree and boiling point is negative 253 degree. 30° will lie where? Positive 30°.
Before melting point.
Uh-huh.
Before melting point. Sorry, before boiling point.
Melting point is negative 259 and boiling point is negative 253. Very, very low temperature. It is definitely a gas, number A, at room temperature. Now you see, you have negative 259, negative 253. And if you go in the positive side of x-axis, it is like this. If you go on and on, negative 253, then negative 250, then here maybe negative 200, then negative 100, then negative 50, then this is 0. Then you are going on and on. This is say positive 50, then positive 100. That's how it goes, right? So we are asking for positive 30°. Why is it? This is positive 30°, which is far above the boiling point.
Yes, sir.
So what is the condition of A at 30° centigrade?
It's a gas.
Gas. So see, if you don't follow the pattern I say, you need to define where is the melting point bar and where is the boiling point bar, and what is the temperatures for a particular substance. Then I am asking you 30°, negative 100, 80. Whatever I ask, where it will lie. So it is lying here. So which is above the boiling point, far up above, right? Okay, now tell me, negative 100. What is the condition? Solid, liquid, or gas? Negative 100. A friend.
Yes, sir.
What is the condition at negative 100?
It's still a gas.
It's still a gas. Why? Because negative 100 is here. Right? This is negative 100.
Yes, sir.
So it's a gas. And 80°?
It's still a gas.
Still a gas. 80°. Yes. Now if I ask negative 255°, what is the condition? Negative 255, what is the condition?
Boiling point.
Liquid.
Liquid. Very good. Who is saying liquid?
Running.
Sanim Ryan. Very good. So you see, negative 255 is, this is negative 253. So this one is negative 254, then negative 255. This one is negative 255, 256, 257, 258, then negative 259. That's how it goes. So it's definitely liquid. 255 is here, in between melting and boiling point. Is it clear?
Yes,
Take
sir.
a clear concept, otherwise you will lose 1 mark. For sure. You will lose 1 mark. And don't, whenever the question will be asked, don't say, think and make this thing. Melting point, what is the melting point? What is the boiling point? Then the mentioned temperature, put it in proper place, then find whether that temperature is in between melting point, above the, in between melting and boiling point, or above the boiling point, or below the melting point. So according to that, you need to answer. Don't be confused. Very important.
I got it, sir.
Any other question from anyone? I hope many understood. Nazif Anzum, do you understand?
Yes, sir, I did.
Okay. Everyone please try to give response so that I'm sure. Iftikhar, where are you? Iftikhar is not here. Okay. ঠিক আছে। তাহলে এটা গেল। এটা you try at home. এটা number 3 টা পুরোটা করে ফেলবা। So 1, 2, 3, these 3 questions are done. You can solve now if you want. So this is all about melting and boiling point. And this is explained here as well, working out physical state of a substance at a particular temperature. Very, very important. Okay, so next discussion will start is diffusion. Anyone knows regarding diffusion? Idrak, what is diffusion? Idrak,
Yes, sir.
what is diffusion?
The diffusion is the spreading out of particles in a gas or liquid.
You will not get marks for this. You need to have
Yes,
clear
sir.
definition kintu, otherwise marks lose korba. Diffusion is a movement of particles from a higher concentration zone to a lower concentration zone. Or you can say diffusion is a movement of particle from a zone where it is abundant towards a zone where it is less abundant. ঠিক আছে? Say for example, if we spray, ধরো এটা একটা room, this is my room, এখানে if I spray air freshener, then soon all the people or this spray, the gas inside this spray will spray throughout the will be spread throughout the room, right? Eventually will spread, and from anywhere, any part of the room you will get the same smell. So it will move on and on unless there is a equal concentration of all the gas particles present in this room. Do you understand?
Sir, I didn't got it clear. Can you mind defining again?
Okay, I'll define it again, but do you understand the concept? What is happening? What is diffusion? If I spray, then
From a low concentration to a higher concentration.
right. If I spray, say here, if I spray here, then this part has higher concentration and the rest of the room has low concentration of my spray, right?
Yes, sir.
So particles will move from higher concentration to the lower concentration zone unless there is an equal mixture of all the gases present in this liquid, in this room. There will be equal concentration everywhere. ঠিক আছে?
I got it now.
Okay, so how will define, how will write the definition? Diffusion, please write it down if required. Diffusion is a movement of particles. Diffusion is a movement of particles. এই যে এখানে ইভেন লেখা আছে, এটাও তোমরা লিখতে পারো চাইলে, বুকেও লেখা আছে, diffusion is the spreading out of particles or movement of particles from where they are at high concentration to where they are at low concentration. ব্র্যাকেটেরটা লেখা দরকার নাই, জাস্ট এইটুকু লিখলেই হবে. You see the particles are moving. So the particles will move from this higher concentration zone to a lower concentration zone. That's why we smell. Smell transfers from one place to another, and always the particles will move from higher concentration to lower concentration zone. So that is the thing. If you have, say, in this jar, so you have bromine, which is brown gas in one side, and you have air in other side. So if you pull out this gas jar lid, then brown bromine gas will diffuse here and air particles will diffuse here. So see, movement of particles from high concentration to low concentration zone. So this part, bromine has high concentration, so they will move towards the low concentration zone. And in this part, air has high concentration, so air will move to the low concentration zone where we don't have any air. Is it clear?
Yes, sir, clear.
Yes.
So এখানে diffusion এইটুকুই আছে, just আমাদের একটা diffusion experiment আছে that we need to understand. So one thing, try to guess or imagine that if two stone, one which is heavier and one is lighter. So 10 kg and 5 kg stone. So 10 kg stone or a man who is bulky can run less than a man who is light in weight, right or wrong? বোঝা যায় এটা? Heavier particles, they diffuse. আমরা যেটা বলতে চাই এটা হচ্ছে এরকম, lighter particles they travel faster. Particles travel মানে diffuse or travel faster than heavier. এটার একটা experiment আছে. This experiment you will get in many past question papers. Many past question papers you will get this experiment. See, this experiment relies on reaction between ammonia and hydrogen chloride gas. So ammonia is a gas and HCl is a gas. What we are doing, we have concentrated ammonia solution which is soaked in cotton wool. So if we soak ammonia solution in cotton wool, from this soaked cotton wool, ammonia gas will start diffusing. Do you understand?
Yes, sir.
And in this this cotton wool is soaked with concentrated hydrochloric acid solution, and from this concentrated hydrochloric acid solution, HCl gas will come out, hydrogen chloride gas will come out. ঠিক আছে? And the gases are colorless. Both of these gases are colorless, but when they react together, they form a white solid. A salt forms, ammonium chloride, which is a salt. So it is in solid state. So you will see a white ring will form here, anywhere in between the glass tube. A white ring is formed. Now we expected the ring will form in 50-50 position. See here 50-50 position, but we can see the ring form near to the hydrochloric acid end. আমরা যদি এটা এখানে দেখাইতাম তাহলে বেটার হতো, whatever. So the white ring forms closer to the hydrochloric acid end. Now what is the reason? What can be the possible reason?
Hydrochloric acid lighter.
Hydrochloric acid lighter. That's why hydrochloric acid run up to this only, and ammonia.
No, ammonia lighter.
Ammonia lighter. Very good. So ammonia is lighter. This is lighter, and this is heavy. Right? So that's why lighter particles, we know lighter particles, they travel faster. So ammonia travels more in a particular period of time than HCl particles, and thereby they met in a position which is closer to the hydrochloric acid end, because hydrochloric acid could not run so fast as ammonia could run. So from this experiment we can say ammonia gas is lighter than HCl gases. Do you understand? Do you understand?
Yes, sir.
Now if we calculate the mass, we will get the same thing. See, if we calculate, even though we didn't learn calculation yet, but we can calculate. See, ammonia, NH3. How will calculate the mass? You see nitrogen. What is the mass of nitrogen? What is the mass number of nitrogen? This is nitrogen. What is the mass number?
14.
14. Okay, so we have one nitrogen atom, so it is 14. And how many hydrogen atoms we have? How many hydrogen atoms we have here? Anyone? লেখা আছে তো?
Three.
Hydrogen কয়টা? 3. Right. দেখো, the mass number of hydrogen is 1. So 1 into how many hydrogen? 3. So 14, 1 nitrogen means 14 into 1, which is 14, plus 1 into 3. So if we calculate, it's 17 units. Ammonia, mass of ammonia is 17 units, whereas HCl, you see 1 hydrogen is 1 plus 1 chlorine, and chlorine is 35.5. 35.5, which is 36.5. You see, HCl particles are much heavier than ammonia particles. Do you understand?
Yes, sir.
The calculation we will do in calculation part, we will do in detail, and you'll be professionals on calculations, no doubt. But for the time being, just we are showing the ammonia is 17 unit and HCl is 36.5 unit. Do you understand?
Got it, sir.
Okay, very good job. So that is what is happening. So that is the difference, and that is what you will get in many past question papers. You will get 4 marks for this question. They will ask many concepts from here, and you get up to 4 marks. So everyone, please come back. We have less than 1 minute. We'll start a new video.